So this is part 9 of PIC game programming, and in this part I'll handle going into low power mode. So after a timeout period when there's no activity, take the device into low power mode, so you don't need a power switch to switch the device on and off. It will just sit there happily taking virtually no current, waiting for a key to be pressed to be woken up again. So starting off with the constants which I need to add. So it's these constants at the very end here, and they define the finite state machine modes of operation. So in this particular part I'm going to be getting rid of the test harness completely and replacing it with the start of the finite state machine. So it's the start of the actual application, so the application is going to be defined here. So the variables being added in this particular part are the mode and the submode for the finite state machine, but that's all the variables that need to be added in this particular part. So in the interrupt handler is where the actual device goes into sleep mode. So it's at this point here. So it sets the W register to the sleep mode, and then it calls set mode, which sets the sleep mode. And this just sets the mode to sleep mode, but in the actual finite state machine it'll get actually put into sleep mode by a call to a function. So next we move on to the actual finite state machine itself, which is this loop here, and this is where the test harness used to be, but now this is actually the main loop of the application. And the first thing it does is it checks to see if it's in sleep mode. Sleep mode is 0, so if it just moves mode to itself and it sets the 0 flag, that means it's in sleep mode. And if it is, it calls the function which actually puts it into sleep mode. Now that will stay in that function until it wakes up from sleep mode, and the first thing it does is it checks to see if the reset app flag has been set, because if it has, then that means it's just woken up from sleep mode and it needs to reset the application in order to start playing the game again. So if it has, it goes to this reset init place marker, and that's just up here, and that's at the start of the initializing the hardware, but after the clearing RAM. And the reason it's after the clearing RAM is that the settings for what level you are on, or whether the sound's on or off, are actually in RAM. So you don't want to clear RAM at this point, otherwise it will clear all the settings from the previous times the game has been played. So after that, what will happen is it will skip that if it's not woken up from sleep mode, and it does the rest of the finite state machine. So I've just put a little token bit of the select application, select mode in this application, just to get the LEDs rotating like they were before, and the game mode is commented out at the minute, so I haven't done any of that code yet. So before going on to explain the sleep mode, just explain the set mode, which is a very simple function. All it does is whatever's in the W register, it sets to be the current mode. So bit of the program calling this can change the mode of operation. It clears the sub mode, so it always goes in as like an initialization sub mode. It clears key presses, so if you're going from one mode to another, you want to make sure there's no key presses going from that first mode to the second mode, because they won't make the same sense in the second mode. They'll mean something completely different, so make sure there's no keys queued to actually perform any actions. And the final part of this part of the programming is the actual going into sleep mode. So this function will get called if it's going into sleep mode, and the first thing it does is it disables a timer. So you want to disable as much as possible, not only for low power, but so that nothing interrupts the actual sleep mode, which isn't intended to interrupt the sleep mode. Tell it to stop timer 1. To stop doing anything with the LEDs as far as animating is concerned. It reads the keys to make sure that the keys are in the hardware is in key reading mode, and then it calls this function to wait for no key presses. So even though there shouldn't be key presses at this time, because it's a period of timeout, it's to make sure that when it goes into sleep mode, it doesn't immediately come out of sleep mode because the key's being held down or something. And then it goes into low power sleep mode, and that's it as far as the process is concerned, and the process, all it's doing is monitoring for interrupts on the GPIO pins, and once it gets an interrupt on the GPIO pin, it will wake up. So when someone presses a key, basically it will wake back up, and when it wakes up, it will set this flag to tell the application that it needs to reset. So that happens from the calling part, the thing that calls this function. We can't actually go to the reset part in this function because we're down a call level in the call stack, and the call stack should be kept at level 0 before you do a reset. And then it calls no keys again, because when we come back, we want to make it was woken up by a key press. We want to make sure that key press has been released before we go back into the application, because we don't want that key press to actually have an effect. We don't want to start a game or change the mode of the levels or anything like that. And it just returns out of here, and it will go through the reset initialization. It will start animating the LEDs again, and the user can see that they're in set mode, and then they can turn sound on, off, change levels, or start a game. And the token part of the select mode, which I've put in here, is when it's in select mode, just as a normal running mode rather than being in sleep mode, it does just a check to see if the sub mode is like initialization mode, which is mode 0. If it's not initialization mode, it actually goes on to do something in the game select mode, but that code's not been written yet. That'll come in a later part. And then because we're in initialization mode, the first thing it should do really is set the mode for next time it comes in here to not be the initialization mode, so it doesn't keep coming in here and doing the initialization. So this sets the next step, and then it just tells it to animate the LEDs in the rotating clock fashion, which is what has been done before in a test harness. So I've written the code to this microcontroller, and when I put it in a circuit, the LEDs animate in the rotate clockwise sequence, and after a few seconds it will go to sleep mode for low power consumption, and then it can be woken up by just pressing any key. So it's gone into low power mode, and if I press any of the keys, it will wake up again, and after a few seconds it will go back into sleep mode again if no keys have been pressed.